Thank you for being here. Next up, we have Kirsten from HydroGraph, who will do her presentation. I hope you enjoy. Thank you.
Hello, everyone. So HydroGraph is a graphene production company, and I'm sure many of you have heard of graphene. Graphene is the strongest and most conductive material that has ever been discovered. So as a nanomaterial, graphene is just one atomic layer of carbon atoms. You can imagine that graphite is billions and billions of layers of graphene. And so if you imagine the ages of man, they've really been defined by the materials that we've used, whether we're speaking of the Bronze Age all the way to the age of silicon, which of course had massive impact across various industries. With graphene, we're not only achieving significant conductivity benefits, but also mechanical. And with nanomaterials, we can really layer on these multifunctionalities to really produce materials that we've never had available to us before. Of course, our natural world is comprised mostly of carbon. Because graphene is predominantly carbon, it makes it very, very versatile. So really almost any material that you can think of, whether it's concrete, carbon fiber, drug delivery systems used internally, biosensors, and more, can all be positively improved with graphene. What HydroGraph does specifically is we have what we believe is the highest quality graphene in the industry, which we produce at the greatest cost efficiency. And we do this with our patented explosion synthesis method, where quite literally we blow up hydrocarbon gases and all of the carbon that was in the hydrocarbon gas gets converted into a crystalline powder. So this is a CAD rendition of our reactor. This is about 2 meters by 2 meters. And effectively what we do is we pump in acetylene, which you would know as a welding gas. So you can imagine that acetylene is bringing a lot of energy with it into this potential reaction. We have electrodes at the top and bottom of these carbon steel chambers that you see inside. The gases pump in, the electrodes fire in synchrony, and the acetylene and oxygen is then destabilized. And again, all of the carbon that was in the acetylene gas gets crystallized into graphene powder that we then pull, of course, into collection. So the best part of this story is really the economic profile. This reactor is significantly less than $500,000 for us to produce. We can produce this reactor in a matter of months. And then even better, our cost to produce 1 ton of graphene is roughly $50,000 US. Our starting price to sell to customers is $250,000, all the way up to $800,000. And the difference in price is really if we add a chemical group, if we functionalize it, if we increase the conductivity. So when I refer to 11 graphene products, we really have our flagship graphene that's produced in the explosion. And then we have different graphene derivatives where we really increase the value. We are currently speaking with more than 60 customers, and about, I would say, between 5 and 7 of those customers are looking for an annual consumption of graphene in excess of 1,000 metric tons. The average customer is more looking for tens of tons or hundreds of tons, and this is going really across various industries. I'll caution, of course, that it will be a gradual ramp up to get to that scale, but fully commercialized, that is what our customers are looking for. And then again, this one reactor produces 10 metric tons. We are looking at new designs that would, of course, slightly increase the CapEx, but more than double the annual capacity. And so I'll kind of gloss over this slide because I'm sure most of you are aware of graphene. Again, it is the strongest and most conductive material that's ever been discovered. And you see a lot of superlative statements. You know, it is harder than a diamond, it's stronger than steel, more conductive than copper. I just always caution with this slide that these are our theoretical limits. So graphene is a relatively new material. It was discovered in Manchester in 2004. Silicon took roughly 60 years to be commercialized. Carbon fiber took 50. And I'm not suggesting graphene is going to take that long. The future really happens faster and faster, but we're now just scratching the surface in what's possible with graphene. So while today we're going to talk about composites, concrete, lubricants, the future is going to be producing materials that we can't really imagine right now. And so this is our team. You know myself, the president and CEO. I've been CEO for roughly 1 year. I was promoted last March. I was the first employee of the company. joining in the beginning of 2020 when we were located in Vancouver. I have a master's in material science and engineering. And then I will also point out Stephen Corkill, who has built and designed all of our reactors. And then, of course, the brilliant Dr. Chris Sorensen. He is a PhD physicist, and he really discovered this at Kansas State University. And I think it's important to point out he was not trying to make graphene. He was studying aerosol gels, and in doing so, he was exploding different hydrocarbon gases. One of the explosions didn't go as he planned. He put that resulting material under an SEM and realized that he had produced the highest purity graphene in the industry. And so this slide is very important because as a new industry, there's a little bit of snake oil. And so this is slightly dated, but I do believe that the information still rings true. This is what we hear within the industry and especially from our customers. So this was a study of 300 companies claiming to produce graphene. They did an analysis of 60 companies, and this was published in the Journal of Advanced Materials. And they found that there's almost no high quality graphene in the market as defined by the ISO. The ISO, part of the ISO's definition is less than 10 layers. If it's more than 10 layers, then it's classified as graphite. They further found that no company produces more than 50% graphene content, with a majority producing less than 10%, effectively meaning that most companies are producing graphite powder and not graphene. We, of course, don't face any of these challenges, as every single time we turn on our reactor, we produce exactly the same type of graphene. We've also produced the exact type of graphene every time we've scaled up that reactor. So we truly produce identical batches at industrial scale that are 99.8% pure carbon content. It is 100% graphene, but there's a small amount of oxygen that finds its way, and we believe that that actually significantly improves our conductivity. And then, of course, we have been tested as pure by various third parties, also internationally, and we have been approved as a verified graphene producer by the Graphene Council. And so really our investment thesis is simple. We provably have the highest purity material in the industry. We have consistent quality, which is virtually unheard of. And if you imagine other production methods, they're using graphite or methane. Both are naturally occurring, so both have contaminants. It might be sulfur, trace metals, but it's extremely difficult to really refine those materials to get to the purity that we're able to achieve in our synthetic system. We also have a fully green footprint. So when we pump in acetylene and oxygen, we of course produce graphene powder. The hydrogen and oxygen has to go somewhere. That is exhausted as syngas. Syngas is not a waste, it's a commodity gas, and at scale we will have an offtake agreement for this. We also have global reach, as graphene can improve virtually every material known to man, and a very strong economic profile. To say that we're operating at 70% margin would be very conservative. And of course, all of this gives us a significant valuation upside. Of course, our CapEx is very, very low. And so this is an equally important slide. This is our partnership with the GEEK, aptly named. It is the Graphene Engineering Innovation Center. And this is really an innovation hub that was spun out of the University of Manchester, where graphene was discovered in 2004. And really why this is important is because it was discovered there, there's erupted a very, very strong hotspot for graphene and graphene-related research. So in this building, we have a lab with our PhD scientists that engage in research that's critical to HydroGraph. But this building, though they have all the characterization devices, all the industrial prototyping machine, there's really everything that we need to fully commercialize a product. And importantly, the GEEK staff has their own team that has direct first-hand experience working with all the commercially available graphenes on the market. So as they've had experience working with us, they've really come to us. And so when I arrived, I gave them 20 kilos kind of for free. And right away, overnight, their scientists started working with our graphene. They've anecdotally told us that we outperform our next leading competitor by a factor of 3 to 4 times, and that we are the most graphene-like graphene that they've seen. So this has been a fantastic ecosystem for us. We have been connected, I would say, with the majority of our customers really through this vehicle. When we've joined, we have been awarded virtually every project that's come through their doors. So whether it's Rolls-Royce coming in, they want an anti-corrosive engine component. The geek really goes through all the specifications and then they select, or better yet, they benchmark different graphenes against each other. In every single project that we've done with a geek, we have outperformed significantly as compared to our peers. And it's also important to note that really all of this research, or almost all of it, is actually paid for by the customer. And so with truly unlimited potential, a small company like HydroGraph really has to focus. What we are focused on very heavily is on composites and coatings. The reason for this is we need to see revenue for shareholders as soon as possible. The average development cycle is roughly 18 months. We want to shorten that time frame as really as much as possible. In doing so, we want to avoid really any regulatory approvals and any ecosystems that are going to function a little bit more slowly. So lubricants, we have fantastic data here, but oil and gas companies historically do move slower as compared to composites and coatings industries. Composites and coatings are great, and as unsexy as it is, industrial plastic packaging, these are massive, massive volumes. You can put in less than 1% graphene and so greatly improve the mechanical strength that you can use roughly 20% less plastic. That's going to lightweight shipments. Customers have an immediate benefit to their bottom line, and it's very fast to bring these products to market because there's very, very few regulatory hurdles to really jump through. Cement and concrete, I was never interested in this previously because the margins are tight, but now we have new data that was published by ASU that we show we are just as competitive even in concrete. The reason I'm hesitating here is because there are regulatory approvals. Naturally, so if it's a load-bearing component, you want to make sure that it's safe really to fully commercialize. So that is a longer process, but again, the scale is absolutely massive. So as we grow, application areas like this will become more and more attractive. And then energy storage, I would say, is a close third as compared to composites and coatings. Again, we have fantastic data here, but the development cycle for a battery, really to produce a battery, you're looking at a minimum of 9 months just in the first stages. So we will do more and more of this work, though, again, we are more focused on composites and coatings. And so to kind of bring this to life, really what we do is we generate the data at the geek because the geek has the expertise, they have the equipment. Again, customers overwhelmingly are funding that. We then use that data with our internal business development team to secure additional customers. If successful, it moves to industrial trial, and then, of course, to contract negotiations, and then we scale up our production. Our pitch is really because we can build these reactors in 2 to 3 months. We can line that up with this 18-month development cycle and effectively scale with customer demand. To give a couple examples, we have been talking with a large automotive company for roughly a year, and this is for the improvement of polypropylene. So polypropylene, you would know as your dashboard in your vehicle, the side panels on the door of your cars. We have been working with this company very successfully that we believe we will have a much larger purchase order come through in the near term that would be associated with an industrial trial. And we do expect that to move to contract negotiations within the next year. We're also in discussions with the world's largest PET producers. PET was started with previous management. We are working on FDA approval. We're roughly halfway through that. Again, you know that I don't like dealing with the regulatory approvals. I think the benefit of this is this was really because we have such strong data, opening the doors with these companies that not only produce PET, but a host of other polymers. So now that we're in that ecosystem, we can commercialize high-density polyethylene, LDPE, and numerous other polymers while we wait for the FDA approval to come through. And I would say the fastest growing is tactile fibers. So we can produce basically nylon PA6, PEEK. We work with chemical companies. We have a lot of interest from aerospace and defense contractors. These are massive volumes, and it's very, very fast to grow. So one of the companies that we're working with is one of the largest in the US, and they have really significantly shortened that 18-month development cycle. And so to kind of summarize, what we spend our time and attention on is, of course, composites, coatings, and batteries. That is not to say that we're ignoring the rest. We have had a PR go out with NEI Corporation, and that is for batteries. And then we also work with lubricants companies. And I'll also say here that we do as much as we can to create a drop-in solution. So with NEI, we have produced a formula really that they can sell to customers, and customers can immediately use that. Not every customer wants to work or has the knowledge to work with a graphene powder. So we will make master batches. We will do really everything we can that they get a ready-made product and they can immediately commercialize. And to go once again back to really the beauty of the system, and it's important to point out, we only sell graphene. We will never be in the business of selling or licensing our units. We take readily available feedstocks, acetylene and oxygen. We have, we believe, negotiated for pipeline access for acetylene that will really significantly improve our margins at a location that we will be disclosing in the next couple months, which is very exciting. This will be a much larger production facility for the company. And then, of course, we convert those readily available feedstocks into graphene. And as mentioned, the byproduct is syngas, which is a commodity. So this is a no waste system. We use every single thing in the system. And as you can imagine, because it's effectively a bomb, we don't really need any energy to start that reaction. All we need is the energy to power those electrodes. So it's extremely efficient, it's extremely scalable. And again, we're very, very lucky that we've kind of stumbled upon, due to the brilliance of Dr. Sorensen, this fantastic method for the production of graphene. And so graphene, because it can improve the mechanical properties of materials, customers can often see a carbon emission reduction savings. If you're looking at plastics, there's obviously energy that goes into producing the plastics. If you can lightweight the plastic, you're going to have that associated carbon reduction. And often this is fully at cost break even. We are, of course, an expensive product. As I mentioned, our starting price is about $250,000. But because you're using so little graphene for these benefits, it is, again, often at cost break even. And our graphene is so powerful. We're often using 10 to 100 times less of our graphene as compared to our competitors. When we look at the energy demand, you can see that detonation synthesis is clocking in at 2.7 megajoules per kilogram for the production of graphene. This is vastly lower, for example, than chemical exfoliation. That's going to be the bulk of graphene. That would be your Black Swan, your Nano Explorer. And then our closest competitors would be microwave plasma. That's going to be your Lighten, your Levidian. And then again, no chemicals or solutions, really minimal energy consumption, and no greenhouse gas emissions. Syngas is not a greenhouse gas. So really our method is, because we produce identical batches at industrial scale, which we really do believe is an industry first, we will employ centralized production facilities. As again, we will be announcing one in the US very shortly, and then we will just be replicating that model worldwide, likely have one in Europe, Asia, and so on. And as I touched on, we will expand our capabilities to include formulation and master batching. And again, all that means is we want to make it easy for customers to use graphene. Of course, everything is patented. The foundational patent was granted in 2016. This is all publicly available. Feel free to look up these patents. I'll also point out reactive graphene. That is one of our derivatives that I mentioned that does come at a higher price tag and, of course, a higher margin to the company. And then a brief view of our history. So this was discovered at Kansas State University in 2014. The patent was granted in 2016. HydroGraph was launched in 2017 under the name of Carbon 2D. We then went public on the CSE in December of 2021. We have then been scaling up our production really since 2022. And as mentioned, we had a change in management in 2024, and we have actually seen our market cap roughly triple since that occurred. And then a brief view on our cap table. I think it's worth pointing out here that we have had a significant amount of our warrants exercised. We have roughly 12 million Canadian dollar value in warrants that are all in the money. We brought in about 2.2 million just last month, and we do believe that we'll start to see more and more of these warrants really come in and continue to fund the company. And so I think really to close this out, we have a number of key catalysts coming up this year. We're going to be announcing our large-scale production facility. We do believe that we have customer contracts in sight that we will be announcing shortly. And again, there will be a number of larger purchase orders that we are working on, and really a lot of commercial news that we'll be announcing shortly. Thank you. Mhm. We do. We do have a business development team, and we're going to continue to expand that. The size of it right now is 2. Luckily, the Geek has kind of served as a bit of a business development ecosystem as well, but we are hiring an additional 2 people in the coming time as well. Any other questions? Mhm. It does. It does. We have a very, very pure material, and we do believe that, and this is an excellent point actually, putting in graphene as compared to a lot of these other toxic additives, just by integrating graphene, again, it's just carbon. They've done inhalation studies. It's non-toxic to people. We can then remove a lot of these very dangerous chemicals that we've been using, whether it's to lightweight materials or really other benefits that we've seen. So we can start to remove some of these additives. Mhm. That's an excellent question. So actually, all of the components in our reactor are produced in the US, and we plan to have exclusively US production really as we scale. And as another point, actually, Dr. Sorensen is a Vietnam vet. So I think that really in the current climate that we're in, it's a brilliant story, especially since we are a Canadian public company and we plan to move fully into the US. Yes. I would say it was a big change in strategy. As you can imagine, graphene is not a commodity. It is an advanced material. You need really strong use cases to convince a customer to use it. We didn't have enough data under his strategy. And he also had a co-location model where we would have these reactors producing on site, which to me didn't really make a lot of sense. I would inevitably add cost. And if you think of the regulations around acetylene, it's a very volatile gas. You need to jump through a lot of hoops to be able to use acetylene. It's much easier and safer for us to really focus on our core competency, which is production. Thank you.